Welcome to Metrology lecture series. In the present video, we will discuss the example problem on limits, fits and the tolerances. Let's see the problem. The following limits are specified in a limit system to give a clearance fit between a hole and a shaft. Hole 25 plus 0.032 minus 0.00 mm and shaft 25 minus 0.062 minus 0.020 mm. Determine the following. First one basic size, second one tolerances on a shaft and hole, and third one is the maximum and minimum clearances. Let's see the solution. So here given data, limits are given. So limits of the hole is 25 plus 0.032 minus 0.00 mm and shaft 25 minus 0.062 minus 0.020 mm. So first we have to determine the basic size. Basic size is the same for both the shaft and hole. So here observe the limits of the hole and shaft here. So basic size is the 25. It is the same for the shaft and the hole. So basic size is the 25 mm. Next we have to determine the tolerances on hole and the shaft. We know that tolerance is the difference between the upper limit and lower limit. So tolerance equal to upper limit minus lower limit. So first we have to determine the tolerance on hole equal to the upper limit of hole minus lower limit of the hole. So in the data it is given the limits of the hole. So upper limit of the hole is 25 plus 0.03 mm. So upper limit of the hole equal to 25 plus 0.03 which is equal to the 25.03 mm. Similarly, lower limit of the hole equal to 25 minus 0.00 which is equal to the 25 mm. Then tolerance on hole equal to upper limit of the hole, that is the 25.03 minus lower limit of the hole, that is 25 mm. So tolerance on hole equal to 25.03 minus 25.00. So which is equal to 0.03 mm. So tolerance on hole equal to 0.03 mm. Similarly, next we have to look for the tolerance on the shaft. So tolerance on the shaft equal to upper limit of shaft minus lower limit of the shaft. So in the data it is given the upper limit of the shaft equal to 25 minus 0.006 which is equal to 24.994 mm. And similarly it is given the lower limit of the shaft which is equal to 25 minus 0.020 mm which is equal to lower limit of the shaft equal to 25 minus 0.020 which is equal to 24.98 mm. Then tolerance on the shaft equal to 24.994 mm minus 24.98 mm which is equal to the 0.014 mm. So tolerance on the shaft equal to 0.014 mm. Next we determine the clearances. We know that when the maximum clearance is the upper limit of the hole minus lower limit of the shaft. So in the data it is given the upper limit of the hole as well as it is given the lower limit of the shaft. And also we know that the minimum clearance equal to the lower limit of the hole minus upper limit of the shaft. It is also given lower limit of the hole is the 25 and the upper limit of the shaft is the 24.994. So let's see. So maximum clearance equal to the upper limit of the hole minus lower limit of the shaft. So upper limit of the hole is the 25.03 minus lower limit of the shaft is the 24.98. So maximum clearance equal to 0.05 mm and minimum clearance equal to the lower limit of the hole minus upper limit of the shaft. So lower limit of the hole is the 25 and upper limit of the shaft is the 25 minus 0.006 which is equal to 24.994. So minimum clearance equal to the 25 minus 24.994 which is equal to the 0.06 mm. So next we have to discuss the one more problem. So let's see the problem. Tolerances for a hole and shaft assembly having a nominal size of 50 mm are as the follows. Hole 50 plus 0.02 plus 0.00 mm and shaft 50 minus 0.052 minus 0.08 mm. Then determine the following. First one, maximum and minimum clearances. And next one is the tolerances on hole and shaft. Next allowance. Next to determine the maximum material limit of hole and the shaft and also determine the type of fit. So let's see the solution. So in the data it is given the nominal size is the 50 and also given the limits of the hole and the shaft. So here upper limit of the hole is the 50 plus 0.02 which is the 50.028 mm and lower limit of the hole is 50 plus 0.00 mm which is the 50 mm and the upper limit of the shaft equal to 50 minus 0.05 mm which is equal to 49.95 mm and lower limit of the shaft equal to the 50 minus 0.08 mm which is equal to 49.92 mm. So first we have to determine the maximum and minimum clearances, and we know that maximum clearance equal to the upper limit of the hole minus lower limit of the shaft and the minimum clearance equal to the lower limit of the hole minus upper limit of the shaft. So in the data it is given the upper limit and lower limit of the hole as well as it is given the upper limit and lower limit of the shaft. Then maximum clearance equal to the upper limit of the hole which is the 50.02 minus lower limit of the shaft which is the 49.92. Then maximum clearance equal to the 0.10 mm. So next we have to look for the minimum clearance. So minimum clearance equal to the lower limit of the hole minus upper limit of the shaft which is equal to the 50 minus 49.95 which is equal to the 0.05 mm. So next we calculate the tolerance. So first I have to look for the tolerance on the hole which is equal to upper limit of hole minus lower limit of the hole which is equal to the 50.02 minus 50 mm which is equal to the 0.02 mm. So tolerance on hole equal to 0.02 mm. Similarly tolerance on the shaft which is equal to upper limit of the shaft minus lower limit of the shaft. Then tolerance on the shaft equal to the 49.95 minus 49.92 which is equal to 0.03 mm. Next we determine the allowance. We know that allowance is the maximum metal condition on hole minus maximum metal condition on the shaft. So maximum metal condition on hole is the lower limit of the hole and maximum metal condition on the shaft is the upper limit of the shaft. So allowance equal to lower limit of the hole minus upper limit of the shaft which is equal to the lower limit of the hole is 50 mm and the upper limit of the shaft is the 49.95 mm. So allowance equal to the 0.05 mm. So next we have to determine the maximum material limit. We know that maximum material limit of the hole equal to the lower limit of the hole which is equal to the 50 mm and maximum material limit of the shaft equal to higher limit of the shaft that is upper limit of the shaft So here upper limit of the shaft is the 49.95. So maximum material limit on the shaft is the 49.95 mm. So next we determine the type of the fit. So here allowance is the positive. We know that when the allowance is the positive mean it is the clearance fit. Moreover, it is observed from the clearances, both the clearances, maximum and minimum clearance are the positive. So it can be concluded that the given pair has a clearance fit. So this is the solution, and thank you.